Ah. There we go. YouTube has a double blind system apparently. I I clicked go live and it's like, oh, you really want to go live? So you should finally have audio and we should finally be live. There we go. Sorry about the screw up, everybody. Are you getting audio now? Hopefully I get a lot of yeses in the chat. I was going to do this over Zoom because it doesn't require anybody to install anything and records it fine and kind of can go full screen because we'll be doing a lot in the terminal. So awesome. Well, I'm kind of going a little right bare machine here. So what I did is I just spun up a EC2 instance on AWS for a couple of reasons, because sometimes our setup doesn't assume that you can get into the server and different things like that. So I wanted to go from square one up. So what we have here is a machine that I can SSH into with the key I used to start it. So I'm on Ubuntu 2004 here locally. So Joe test key. By default on EC2, it creates a Ubuntu user. You always type that wrong. Ubuntu. And my IP for this guy is here. And what I've done on this one, I've opened up the 35,000 quad 7, 8, and 9 ports, but I also opened up 22, but only from my home's IP. If you don't have a VPN in a security, you want to try and punch your ports in as little as possible. So if you take your internet provider as your incoming port only you can get in there, which is a little bit of a security piece there. So we'll add this to the host, but each time you come into your server, you don't want to type that mess, right? So inside your SSH, you should have a config file, and if you don't, you can create it. I backed mine up so I could create it here, and we can create a host file. We'll call it test node. We're going to go to host name, which is the IP, what did I have, 18.188.234.145. So we're going to use user, we'll have Ubuntu on here at first, so it'll get in, and then we'll change that identity file. So I'm going to go to the file I used before, Joe test key him. I think that should be right. So now instead of that whole long string, I can go into test node. Oh, too many 8s there. I created an IP address from, what was that movie back in there with Sandra Bullock? All the numbers were too high. The net, I think it was, yeah. So test node. Now we're in like we were before, but we don't have to remember all that whole string every time. So first problem that we run into with people setting up nodes is logging in and using root user on the node. Bad, bad, bad. Don't do it. Bad. Totally breaks the Linux security model. So first thing we'll do is create a non-root user. I already am one on here because EC2 does not let you log in like that. But say we're going to add user. I use Sacher JJ for a lot. That's been my username for a while. So we'll do that one with a disabled password, because we're going to come in with a key, and you actually have to spell sudo right. There we go. Don't care who I am. We're good. We have a user. So now I can become myself here, sudo into my user, and I want to make SSH directory, right? Because we want to be able to log in with keys. So chmod just for me, SSH. And then we need authorized keys. So let's make a key pair to connect those two. So SSH, was it keygen? I should have prepped some of this, I guess. I think it's a dash, isn't it? So we'll call this ID, ID Sacher JJ RSA key. I won't worry about a passphrase for it. So we have that key. And so we can now look at our pub key from that. and we're going to need this to add to authorized keys. So we will authorized, you have to spell this right or SSH doesn't use it. So we make a new authorized keys folder, we put in our public key, and we should now be able to log in with that user. The first exit was to come out of my Sacher JJ user back to my other one. And there's a few things I want to do before I log back out. I like my default stuff to be VI. So alternatives. By default, it'll be nano, which may be easier for some people, and that's perfectly fine. And then we want to VI sudo, and add our new user to have sudo privileges because we don't have a password. We just want that to happen automatically. So all, no password, all. Okay, save that, and we will exit out of the server. So now we're back on the desktop, and we created this config to get in here. So we're changing this now to the new user, and the key is going to be SSH, what did we call that? ID, Sacher, JJ, RSA, I think, right? So we're in now as the Sacher JJ user. So if Ubuntu was root, we are now not root. We're in the right position to set up a node. So first thing we need to do is get access to the software. So we have repo.casperlabs.io, which allows you all of these things to get the sources, get the key for it, all that. You can grab the whole deal, copy it, and go plop, and you're there. So now you have our repo added, which gives you the ability to install Casper Client and Casper-Node Launcher, and so we'll do that. So Casper Client, Casper-Node Launcher, and then I'm going to install JQ, which is a JSON parsing utility that is very, very helpful. And that will all come in. Casper Client only puts one file in as an executable. Casper-Node Launcher puts quite a bit more, and that's what we'll be covering most of this on, how to configure it, what goes in there, that sort of thing. So we'll wait for that to finish. All the video and audio still coming through for everybody? Good. Okay. So we're going to go into the configuration directory first, etc Casper, and we're going to ALR, so we'll get recursive of everything that's in there. So we have configuration scripts here, our scripts to configure, and then actually configurations. So one change with what's on mainnet is that a lot of mainnet nodes started with the 0.3.2 version of Casper-Node Launcher. This, I believe, is going to be 0.4.0. Oops. Yeah. So with that, I added this file and a few other tweaks. So we're trying to take away the stuff that you just have to remember to do, but we can remember for you. And part of that is platform. So we have a working node on Red Hat. We haven't released it publicly yet. We're going in packaging for it, but what we're starting to add is platform pieces here because we're going to need to know what platform you are to figure out what binaries we pull down when we stage nodes. So we're starting to build in more intelligence that allows you not to have to think about things, which is good. So we'll be going through these scripts. We'll also be looking at the new node util and a few things I want to do with that. So I'm going to curl that down from my current operational branch. And I probably have to chmod that, yeah. So we're going to make that executable. Oh, I'm in. So, yeah. Node util should be executable, and it'll print out what all commands we have, and we'll just keep adding commands to this. So it's kind of like get, where you have a command, and then underneath that you'd have subcommands for it. So check for upgrade. We can run that, and it'll tell us that we need a config file. So if you were in mainnet node with 0.3.2, what you may be used to is something that was pull Casper-Node version, and you would say, I am version 100 Casper. And that was pinning the URL where we hosted all of the various networks. And when Make Services launched the testnet for DevXDAO, the place that you pull the file stage were different. So with 0.3.3, we introduced network configs. So here you have Casper config, and if you had Casper test, you can see that we're hosting files for certain networks here. Make is hosting here the stage files for Casper test, and any other public networks that are using Casper can do a PR to the Casper-Node launcher, and we can get the configs in here. You could also have a config for a private network. So if I drop in like a pull of our integration test, which we control access to because we control the token on it, you would have a private config that would work with all the scripts we have. So what we're trying to build is something that's flexible, that you can use all these scripts for nodes, even if it's like an internal private network, right? Still all works the same. So most testnet users or new mainnet installers would use this new config format. And that's part of why I've had to put out stage upgrade scripts for mainnet so that it could detect which version you have and change across. And our goal is to have this released, the newest version with the new node util and all of that, way in advance of 1.4 coming out, so that we're all back on the same page again. So if we're going to run a node, regardless of if we have any token with it, just standing up, we need some keys. So the first thing we need to do is create a key pair. So inside validator keys is where they would live, and you can use the client to do keygen in this folder. And it's not going to let me because I don't have permissions. So actually, let's do that just with sudo. So what you'll notice here is that read write for root, which is the safest thing to do for a secret key, if we tried to start this with the Casper node, it wouldn't work because it can't see the secret key. And time again, I'm not sure exactly how, we have files under etc Casper, the binary location, which we'll look at, some other places that are not owned by the Casper user, and that causes problems. So one feature I added to Casper-Node util is check permissions. And it will look at a few key directories and look at the permissions for it. And if you try to fix permissions without being root, you aren't going to have the permission to, no pun intended, so it reminds you. We can sudo that. Now it's going to go through, tell you what it corrected, and whoops, didn't go one above, there we go. And we're good. With the latest version, I actually print out a message, all's good, right? Not just an empty output. That'll solve some problems very easily. It's hard to explain people sometimes a recursive chmod command, or like a chown, Casper, recursive all the way down, right? This is one command to fix it. And so that's the goal of node util, is to keep building in errors that we see. We don't know necessarily why they're done or how they're done, but we can fix them. Because if you follow our scripts directly, usually it just works. So the old method of staging a version that I'm sure many of the node operators in here are used to. Sudo. We always sudo u Casper, anything that's going to create files, because they need to be owned by Casper. I'm in a habit of doing the full path because sometimes I'll execute it in a different folder. So we'll go directly to the Casper network, and we're going to pull the Genesis version. So what this does is it pulls binaries into varlib Casper bin with the right symver, and then right under here, configuration files with the right symver. And only the first file for a network has accounts TOM. Well, that sets up your Genesis accounts. And once Genesis happens, you can't change those. So you only see that with the first version. Now you see chain spec toml, which is the configuration for the network, which you cannot change. If you modify it, you won't sync up with everybody else because it has to be proven to be exactly the same. So the hash of it needs to be the same. Config example is an example of what config should be, what default value should be. But there's one thing in it that needs to be changed, which is why it's not called config toml directly. If you look at it, we can grep for is it local address, something address, public address. So we have this IP that we need to replace with your IP. So if we go back to the scripts, we have sudo u Casper, because we're going to be creating a new file, config from example, and we need to tell it the symver that we're going to make the config for. And that's going to go through now. So if we cat local, no, public address. So now we've got this here. Occasionally we have users that are in a network address translation environment. So you may have a server that has this address, but it doesn't expose ports directly to the internet. And you may come in through some other IP that routes into here. So we have a second argument to this that is the IP you want to use. So instead of auto detecting, which this goes out places and auto detects your IP, it actually just uses that. What you also see is that we've created a config toml new rather than overwrite the old one, and you would have to manually replace that. So if we look at the differences between these, see, it's just IP. It just swapped a different IP. And in fact, we can clean up that one because it would not work. So that's an IP I made up. So we have a version staged here, and you can see the accounts chain spec config example. I'm not going to go through the accounts toml on mainnet. It's really huge, but that defines kind of the startup accounts of pieces. And we can start the node and get it going, and then we can describe some of the other pieces, and we'll actually not work the first time we start it, which is kind of part of the point. Start Casper-Node launcher. Nope, missed it in. Okay, so system control status. We have a failure. So we need to figure out what we did wrong. And before I get to it, if anybody can do it in the chat, I don't know what you win. You win pride. So we'll go to var log Casper, and we have two files in here. Casper-Node stand error log is actually a teardown of what crashed when the node exits out. And if it errored out but cleanly, then it would just say this errored, and you need to look in the normal log to find it. We can find the answer to this in both places. We can look at the error log, and node panicked should have trusted hash after Genesis era. If you didn't start with the network, you need a trusted hash to get into the network. And we've loaded a bunch of those on our nodes, those that have operated it. If we cat the actual log file of the node itself, it's going to have a lot of information on it in startup, but we can often filter into what we want with grepping on error. And here we see node started with no trusted hash. Please specify a trusted hash. You notice we have 3 errors here in quick succession. So this is within a few seconds each. Systemd is set up when it runs your node that if you don't restart, if you restart 3 times within 30 seconds, it will shut your node down. But if you're slower restarting than that, it will automatically restart your node. The reason for that is if something errored out in a way that could be recovered with a reboot, we can reboot the node and continue going, right? That's the safest mode of operation for it. Unfortunately, if you have a slow error that occurs, such as if your ports are not open, you will not be able to interact with anybody, and it restarts on like 2 minutes, I think. And that one you kind of have to poke around for or look for errors inside the log, but it's going to continually be running, so you may think everything's great, but it's not syncing. So we'll look at how to address that as soon as we get a node, or get a trusted hash. And I should have pointed out that the wiki for mainnet installation instructions is kind of what I'm going through. I've just done this so many times that I'm doing this simple command of pull node version and config from example. But what we have here is this while loop, that there is a file we store that has all protocol versions. And the reason that's important is in testnet, in integration test, we had tested a version that we did introduce a bug for. That's what the environments are for. So we have a 131 that kind of had spammy messages, and that is not released in mainnet. We jumped past it because it was a buggy release that we knew wouldn't go to mainnet. But we would need to install it to be compatible with all the platforms. So we can't necessarily assume that all the protocols are the same on all of those. So we keep this protocol versions file. And this is a bash script that will look for each line of that protocol version, do the 2 steps we did manually. But that's not quite as clean. So Casper-Node util will kind of help with that. The first thing we'll do is get a trusted hash. So we're going to walk through doing this manually. We have this whole command, which, I didn't want to have the new line with it. But if we walk through getting what a trusted hash is, that's simply a block hash that we trust from somebody. So we cannot run the Casper client on our local node because it's not running yet. So if we try to run get block, RPC is going to fail. We don't have a server running. So we have to point to a server we trust. This is a server on mainnet. So if we get a block, we're going to get this full piece. And until we have fast sync going, we actually sync much faster with a lower height block. Fast sync will be coming out, which will fix a lot of our sync performance issues, but we can specify a low block, say block 20. And where before you saw, what was it, 174,000? Yeah, 174,898. Now we're at block 20. But you got all these things to go through, all the proofs and different things. So we want to drill down on that to get our hash of the block out. JQ is a utility that parses Java or JSON format, and this is the whole thing just prettified. But we know we want the result of this, and we can look at where we drill down. So result, we're going to go to block, we're going to go to hash. So dot block dot hash. We've got that. We don't want the quotes, so we can tell it to go raw. And we don't want the new line, so we can delete out with translate the new line. Oh, the wrong slash. There we go. So you can see that the new line isn't here. So what this command does is give you the trusted hash of block 20 from this server. What I'll be adding into Node util is the ability to say server IP, but also a network name. Because one common thing we have is if I ran this command on testnet, I'm getting a hash that's from the completely wrong network. So you have to be very careful on which one you're getting because you can never sync to a hash that doesn't exist on that network. So to be able to get this into the file, we're going to use a sed command where we will look for trusted hash in the file. And let's see. So we're going to search trusted hash somewhere in the file. And we're going to, I'll put an equals there, so if it's in the middle of a comment, it's not likely to find it. We're going to replace the whole line with trusted, yeah, get it right so it actually works, hash equals quote, we'll put something in here, Joe is cool, right? Oh, I didn't want to do a new line. There we go, Joe is cool. And that'll be our full line that we're going to insert in there to etc Casper 100 config toml. So we'll get an output of it that is Joe is cool, right? So it replaced the one that was in here that was commented out with this. So we need to get our trusted hash into there. So we can get this piece that we had for trusted hash and we'll replace it with a subcommand. And now we will get the actual hash put in there. So that's how that works. If you've run that command and not known what was going on, kind of wanted to build it up for you. One thing we do is we go I, so it's inline rather than printing out, but that is going to give us an issue. So we have to, because we don't have permission for it, we don't have to sudo-u Casper it because we're not replacing the file. It already belongs to Casper. We're just processing this on it. So now if we cat the file, we will have added that in there. And, oh, not slash, it's this local directory. Okay, grep trusted. So we have that. The reason I showed you the buildup of this command is because you may want to use something like this for your scripts. So if we actually cat the full config file, while the values have changed with the later configs, something like event stream server. By default, we hold 50,000 buffer in there. If you're going to really feed off the event stream and want to have it there, you may want this to be 50,000. So you may want a command that is sed, we'll find event stream buffer length, and we'll place the whole line with event stream buffer length equals 50,000 for, and you'd probably want to script in the protocol version here, or have this run, right in that place. But assuming I did everything right, now we're at 50,000, right? So you may have a set of configs you want to do. You would have to obviously see, did values come in or out of the config, but it allows you to kind of set up a small script to, you get your IP in the config, but then you can kind of configure it and make it your own, right? A lot of our mainnet nodes we have as an event stream saving node, and so we want that buffer to be large so we can, save those out with no issues. So we added trusted hash in there, so we should be able to start. And I guess I didn't mention, if you're not used to Control R, this kind of reverse searches your bash history and is awesome. So I did Control R, type start. The most recent command that matches that is there. Hit enter, and I'm running it. And that's just awesome. I can't live without that. It drives me nuts to not have that ability. So we're going to do the same thing for status. And we can see that we're running. And as I've noted in, actually, we'll get the watch after we get the other staged. So previously we had this loop, right, to stage these. So the idea with the Casper-Node util is that, I forget what I called it, you have check protocols. So node util check protocols, which will use that check. Oh, config. It requires the config because this will work for any network you have, right? So if you defined a config for the network, so we're doing mainnet, so we'll use Casper config. So it's going to go through the protocols and tell you their state. Now, if for some reason we staged not only the binary on this, it'll tell you that, or config only, or whatever. But if you use the proper scripts, you shouldn't run into that ever. So it should be fine. So we could also check for upgrade, and it only checks the last one on this, but what is it, $? For the exit code. So that's exit code 1, meaning you could have a script that's looking for upgrades, and if it got a 1 back, it would say, okay, I need to alert using my alert system. Or you can stage protocols. I can't do it without being sudo u, so it told me. Now it's going to pull down and stage all the protocols. This is effectively doing what this while did with all the scripts that are there. And now if we check for upgrade, we can echo the return code, and it's 0 now because there is no upgrade available. But you can run stage protocols as many times as you want, and it don't hurt nothing. So if you wanted an auto upgrading server, you now have the ability to do that with a cron command. If you want to be told when to upgrade, you can check for protocols, check for an upgrade, and have a response off of the return code of that. Allows you to control it how you want it. And we will never auto upgrade without opt-in, but people have asked for it, so I'm building it. So we have a watch statement that, did I already start the node? I believe I did. Status, or wait, system control status, but we'll cheat. Okay, we're running 3 minutes, 14 seconds. So there's a watch command, which is really nice. You have essentially pulling together a bunch of things. I'm creating labels, and then I'm curling the status and processing them, and we'll walk through that a little bit too. But it gives you a way to follow the sync and what's going on. So this is just counting the peers. If you don't have many peers, something's probably wrong. It's a good indicator. This is the last added block, and you'll see it going up, and I'm sure many of you have synced through this. The Casper-Node launcher status is important for a few reasons. So we talked about the restart that'll happen if your node isn't erroring rapidly. So if you have 3 errors within 30 seconds, it's going to shut down. You're going to have, I think it's failed here. But it could restart at, say, 6 minutes for something. I know we had a consensus shutdown in the past that if something didn't participate, it would shut down, and then this would restart it. And so if you looked at this, you would see active, and if your check script didn't ping it at the exact time, you would think, oh, I'm good. But you're not progressing. You know, you would obviously see that with this not increasing. But with the active line and your debugging, looking at this value is important. That should continuously count up. If you come into here when you're expecting it to be syncing and it's not, so we started it, let's go start. So we'll restart the node. So say we didn't restart it, it restarted on its own, but we're coming in here, oh, it's active, it's all good. This should be almost 5 minutes now. So if I don't see that as the time from when I started it, I know it restarted. If it's 30 minutes or an hour or whatever, it restarted and recovered, and it's probably fine. If it doesn't get above a few minutes, you've got something going on that you need to look at logs for. The other part of this that's very helpful, you can tell what protocol you're running. So the way the Casper network works until FastSync is released is that you need all binaries and configs that have ever run on the network. The reason for that is we essentially do what's a hard fork on other networks at each upgrade. We do it synchronously, we do it automatically, as long as you staged it. So when we get to the upgrade point here, this shuts down cleanly. Casper-Node Launcher starts the next version and goes up. And actually some of the watch commands I have, which I guess I need to update the wiki, has the upgrade point. So we'll put that in here. We're gonna curl local status, 8888 status, and then JQ, I think it's next upgrade. So we can see the activation point. So at 346 it'll shut down and it'll cut over there. So let's poke into some of the ports that are available there. The Casper client goes to port quad 7, and since we have let's do git block, we have our server running, but it's not synced. We don't have RPC yet, so we still have to go to a different location. That's an indicator that you're not up and synced, because you don't want to be able to put deploys to a node that's not at the tip of the network. Now your port 8888, your status port, is active immediately, and so is your event port. So we can look at localhost 8888 status, and there's a lot of stuff here. We can JQ it to make it a little prettier, but it's mostly dominated by peers, right? And there's a filter I've done with JQ that I've got somewhere that deletes this out so that your display is a little smaller. That's also a feature I want to add to Node-util, that it will kind of do a little bit this for you. And this is what we're looking at in our watch statement. So to get some of these, we can drill down to API version if you wanted. So you can find that directly. You can get to last added block info. And this stuff you've seen before with our watch statement. But if for some reason you wanted to use this in some kind of process to monitor, you can drill down on it, whether it's JQ or not. The other thing that's available on our REST port is the metrics. So this isn't a format you could suck into Prometheus or any system that uses a standard time format metrics and get a lot of data about the node. And so we've done some videos and demos on setting up a basic Prometheus Grafana stack for that. One thing we get often by people is they look at the status Casper-Node Launcher. So they look at the status, and this memory can grow very large, or the total RAM bytes, and what it actually winds up being is Linux efficiently using cache properly when it's running. So we have memory mapped to databases, and you can actually use some of the metrics to find the actual memory. I didn't really prepare for this piece, but total memory usage, let's joiner. Anyhow, it has the memory inside of there. But when people see the memory of the actual Casper-Node launcher process getting close to their whole system memory, it's just Linux using it because nothing else is using it. So it's making your storage faster and not really a problem. So we are still syncing up. We have not talked about where the binaries live, other than that we see them there. So var lib Casper, start there. And inside the bin folder, we have all the symvers, and then we have the given binary versions of the Casper-Node. And then inside the Casper-Node folder, we have the database. And this looks huge. Let's go into Casper-Node and figure out what's going on. This is, again, the memory mapped stuff going on. People will be, if we do this as was H human readable, 1.1 terabytes. What the heck? But if we look at the disk use of storage LMDB, do we do -H? I think it's 16 meg. But it's virtually memory mapped to be that size. It's a sparse structure. So if you're playing with those, it gets kind of confusing, and you have to make sure you're using sparse flags when moving them and that sort of thing. But it's a feature of making it more efficient for the system. So don't freak out with huge file sizes. So go into the binary. We've got the various binaries that are going to be run with each of these. If we go into 132, we can look at the README. So that's going to give you the get hash that it was compiled to. If you're running on a platform we don't build for, you could pull down this binary and rebuild it to be compatible with your system before the upgrade point. And we can actually run this Casper-Node to get the version. And you'll see that it's got the version number and got this going with it. Oh, I just saw a question pop up. A way to check that the node had been equivocated. We've actually discussed that today, that when you have a doppelganger that both are running, it should detect that and should not equivocate. So we may be able to fix that to be a little better for an error message, because when you get equivocated, there's a 16-hour kind of jail you put in before you can join, which I think one node recently went into there. Let me see if there's which server y'all trust, which security keys, supply. Don't know if I understand. So what's inside the DB? I haven't opened that. I let it create them and delete them. I haven't poked in there. I don't have a way of viewing it easily, so I can't quite do that. Sorry. The core dev guys would be able to kind of poke into that more. Let's see, what else did I like to do log rotate each time I start, which I haven't here many times. And the reason for that is that it gives you a fresh error log. So if you're debugging and you're trying to figure out what's going on, rotating the log is a good plan before I start. If it's empty, you haven't crashed. But like if we look at the one we rotated, you can actually, when you guys type, it pulls my cursor away. So we can zcat ones that are already compressed without having to uncompress them, which is handy. So if you've had a crash, you don't have a timestamp on the crash log, so you don't know exactly when it happened, where the regular log has those pieces. And it's easier to have it rotated and have it clean, so you know that you did not error since your last start. Now, since our log is JSON based, you can Casper-Node log, and it's going to parse each of these like a separate JSON document, which means you can do things like just dive into the fields message, which would allow you to, wouldn't plan on this, but we'll see what we get. If we go raw, we can then sort, and what, unique C, I think? Yeah, I think you could sort that reversed. So this would be your biggest log message. This is your second, you know, the number of occurrences. So if we're looking at something going really wildly wrong, we can see, okay, we're doing a lot of this, so there's probably an issue. We have crosstalk, which we'll be kind of fixing with FastSync as well, so you'll see a lot of that, and it's not really an error. What happens is you have a, say, a testnet node that is promoting itself to a mainnet node, and it has an old known addresses. And if we look at testnet, we can see that there's a considerable number of nodes that have never upgraded from a given version, and they may link with what they think is a testnet node with a mainnet node, and that's where we get the crosstalk that the 131 caused issues with and that sort of thing. So this is a little utility I built that allows us to see what's going on before upgrades. And I need to production harden it a little better for hits so that everybody can come to it. But we can see, like with the upgrade this morning, I could see people that were staged 1-2-1 stage for the point and see them move over. This is how we know that an upgrade is going to be successful. We can see the weight that is staged for a given one, so we know when it's a go, and that's how we get some of the values that we've had. Kind of little utility site that I have. Okay, what else do I have on my list that I should cover? Events. We didn't cover events yet. So we covered the quad 8 port, which is your status and metrics, but the most, I would say, unknown port or unused is events. And so server sent events is the event format that we use on a node. So the easiest way to do that with curl is N for a non-buffering. So we can go this. Prior to the 1.3.2 upgrade, you would go to events. Oh, we haven't upgraded this node yet. It's still on 1.0.0 and syncing, so that still works. Like, why the heck does that work? So let's go to a live network rather than a syncing one. So this is a live node on integration test, I believe, and it's going to tell you now with the 1.3.2 that we have broken into 3 separate event streams. So main is the same as it was before, with the exception of finality signatures. So what you get is these are emitted as the node reaches them for various events. A block was added. This was an empty block with no deploy hashes. This one, we had a deploy processed. Here's the data for it. And the block that was created after that deploy was processed has this in it. And I think I just drug this over. Okay. And if we look at finality signatures, what is, actually, I guess it'll tell me SIGs. Finality signatures are what occurs if you watched or read through Meta's tweet on this. She has a good Twitter thread on how we do our finality and our execution and stuff, so we can't tell. It's first in, first out, and we can't preferentially execute anything. But a finality signature is when a validator signs what's in a block, and their weight then is combined and it moves forward when we have had 67% or more weight say that this block is good. That's part of the consensus piece. So you have a given block in a given era, the signature of the validator and the key of the validator. And so those will come through with the blocks. And when you actually query an older block using the RPC interface, you'll see a list of all the signatures in there as well. And then we added a new one that is deploys, which has the full deploy deploys. You notice I have a start from 0 on theirs with the setup. If you don't start from 0, it would not go back at all, but that's the buffer amount that we talked about, where you can replay it. If your processor goes down slightly, you could catch back up and go through it. So we can look at deploy accepted. A lot of these look like they're simple transfers because there's not a lot of data with it. When you get a WASM transfer, you'll have this whole, this is the WASM bytes in hex. It's massive. So you get a record of the whole thing that happened, and it's a lot of scrolling going on. Anyhow, that allows you to hook pieces up to it. And say you wanted to know that your deploy for a transfer or for a smart contract execution happened. So you can see when the deploy is accepted. If you send it to a different server, you definitely know it got gossiped back to you. And in the main piece, you can see a deploy proposed, and you can hook onto things that are event driven rather than having to pull the RPC and implement it that way. So the question came in a little more detail about file sync. I don't have the full picture on exactly what FastSync is looking at right now. Ed and some of the other team, I think we can get some better communication out to clarify that. Essentially, what you're looking at is not having to sync a node from Genesis. So there's enough of a history and a consensus pattern that you're securely in the node, but you don't have to do that whole sync from Genesis, and that's the intent. We also are looking at what it means to have an archival node then, as far as having a record of everything that's happened on chain. So there's going to be a certain set of servers that keeps that record. If you want to see what happened on block 100, which actually for mainnet it wasn't much because we were token restricted for a while, but say May 30th when everything went wild, right? We could look back and do that. And so there's a few things that would occur for failover, both in like the validator side, but also delegators. So right now we have an undelegation delay. So if a validator has a problem and you want to jump ship, you have to wait to undelegate before you delegate back again. And it'd be great if we could lock funds for a certain time, but also point over, switch delegators. And that's something that we're going to have to solve on there and look at what the implementation cost and lift is to make that happen. But that's on the delegator side of it. With FastSync, your sync time should be very rapid. So sub-era rapid, which means that if you detected an issue, you could, as long as you had a node spun down, you can spin up another node. And in fact, on AWS, we have a AMI instance that will basically start your node for you. You put in a few pieces, and you can script that. This isn't a whole lot of commands to get a node started, right? It can be a fairly simple script. And as long as you didn't run them at the same time, you should be able to script setting everything up, copying your keys in, and then syncing. And then you would have to have a detection mechanism to see, am I still active? If I'm not active, I need to activate bid, right? That sort of maintenance piece. But the idea is we don't get in a scenario where database corruption or some type of equivocation or something, because we're trying to, beat the sync delay, which we understand that 5-6 hours of syncing is a long time. And that is, 3 errors that you're going to be out, and then you're going to be able to bid in, and then you're still 2 more eras of rewards before you get going. So we understand the pain there for that, and that's exactly what FastSync is about. And as we keep moving, down the chain, it's going to get longer and longer and longer, right? That's why this 140 focus is all on FastSync and on RPC improvements. And then from our team, it's about packaging improvements and the node utility, different features of that will help. So, actually rotate logs I have in there because I always forget the command. I was trying to think if there's anything in there I hadn't talked about. So delete local state is the same as the delete script here. Rotate logs. The one thing I'm going to be adding is getting a trusted hash, which may or may not be required in the same way with FastSync. So we'll see how that goes with it. And I'm open for things you do or bugs you've seen that we can possibly put some diagnostics into here, that sort of thing. So any feedback you have for that or any features you'd like to add. And in fact, I welcome PRs once we get this up there. What we essentially have, I'm trying to make this a 0 package install. Everything is standard lib in Python, but what I have is a class that kind of hacked the argument parser a little bit. So the usage docs that you actually see here are actually coming from the method doc strings. So if you have a method in Python that has an underscore, it's an internal method. And if you have a regular lead, it's a full-blown method. So you see stage protocols, stage available protocols if needed, and that should look exactly like this because it's actually pulled right from there. And then I do want to get a little better tooling on the arguments in the sub piece. I think I can make this a little cleaner and less repetitive. but this allows you to make custom arguments for that one method. Now this is its own kind of standalone piece that can do whatever it wants in various exit codes. So it's very easy to say, I'd like this functionality. It can be self-contained, but also with various helper functions like config from example script. This is a Python replacement of what the shell script did before, right? This is get external IP, which was in there, and extract tar.gz. If for some reason you've got to pull that out for the configs down, pull protocol version. So I've made Python versions of all the functionality I had before. And so we can just keep adding to this. But I want to keep it as a one script thing that requires no added files. The one that's really painful is a TOML parser. That'd be great to have, but I'm kind of string parsing it away. So anyhow, kind of covered what I wanted to cover on that. I hope it was beneficial for you guys. I know we've got like a 10-second log or so, but want to see if anybody has any questions or anything else I can answer. And I also welcome any kind of feedback in any of the various communication methods that you guys all talk to me to. So wait a little bit for that, but I think I'll about wrap it up. I guess we're hit about, we're hitting right about 3 o'clock. Looks like Ed's covering a lot of the stuff in chat. Thanks, Ed. Okay, notify of a node going offline. Email notification we can plug in. I actually registered a domain called CSPR.care as a personal project that I'm looking at plugging into this. Don't know how soon I'm going to have time to plug with it. I'm taking vacation next week, and oddly enough, when I'm not doing work programming, I actually do relax a little bit with personal programming. So I may plug with that a little bit. But that's kind of idea I have, not just for validator side of things, but also for delegators, where you could register with a key and get status of your validators, new delegators coming on, potentially subscribe to balance changes, that sort of thing. And so I'm not sure exactly what that's going to flesh out to be, but I know there's a big need for it. In fact, Meadow told me she'd be my first user of that as she was delegating the various tokens from the various organization and different things. She realized that having that would be very useful. And some of the work that I've done for the Casper Network Monitor with looking at historical status, uptime, and different things, we can get a feel for, what's going on with it. And then you could subscribe to that as a delegator to your validator or, whatever. We'll figure out what that is, and would be a way to do a notification that you've been marked as inactive, or for those that are in right on the bubble of the auction contract, right? They may see that they've shifted down a certain number of users and they need to lobby for delegation or try and get more Casper in there. There's a lot of use cases that having a good notification engine I think is useful. So I'm going to try and kind of get a minimum viable product of that out, and then we can build on it. So the first piece I started with that is I would think would possibly be Telegram and email notification, mainly because they're free-ish in implementation, where international SMS and a few other things would have a decent cost to it. So I'd have to look at monetization to cover it and that sort of thing. But hopefully within the next couple of weeks, I will have got the first piece in there, and I can ping a few of you guys to help me test it out and see what's going on with it. So I'll give you guys a few more seconds. Lightning memory mapped database. Okay. I'm reading back on the history here. So hopefully this is beneficial. This was kind of one of the first things we did with IBM as we tried to onboard their developers to the platform, because I think a good understanding of how the node's structured, where the files are, what's going on with it. I mean, it's the core of the system, right? It's the hub of everything together. And we have the weekly DApp presentations on Discord that are, I think, Thursdays at 10 o'clock my time, I believe, so 3 hours before this, where we're trying to do the same thing with the developer community. And each time we find a rough edge, we're trying to smooth it over to make the ramp onboarding and the use and everything as simple as possible. So I'm going to wrap it up. I really appreciate your attention and questions here. And we'll post in the recording of this so people can review it and hopefully gain something from it. And I'll decommission this new EC2 instance. Take care, guys.